Okay, in this video we're going to be looking at electron arrangements. And this is how electrons are arranged around in an atom. Specifically, we're going to be looking at Bohr's model. So, there is, again, attached, there's a periodic table at the bottom. This is the OCR A-level periodic table. I'll keep on referring back and forth to this one. Some bits might be slightly different if you've got your own copy of the periodic table. If you haven't, download the one at the bottom. Okay, so this is my absolutely horrific drawing of an atom. And at the centre of an atom, we've got our nucleus. Now, in the nucleus, we have our protons and neutrons. They live right at the centre, all together in the nucleus. And then the electrons, they orbit around. And Bohr's model says that they orbit around in shells. And Bohr's model only works for the first 20 electrons. So in this first shell, we've got here the one very closest to the nucleus. The first shell, you may see these referred to as letters, but we're not going to go into that. The first shell, we have 2 electrons, or it can hold 2 electrons. In the second shell, the next one along, this can hold 8 electrons. So as they get further away, you can kind of hold more and more. The third shell, actually, we say can only hold 8 electrons for this model. We'll look at some versions later that suggest it can hold more. The fourth shell can hold more, but we don't go into it. If we go too far into fourth shell, the shells start to break down. It's not really a shell anymore. But for this, we can look at the first 2 electrons in the fourth shell. After that, this model doesn't work anymore, and we don't use Bohr's model for more than for atoms containing more than 20 electrons. So you can see here we've got 2 in the first shell, 8 in the next, 8 in the next, and then 2 in the final one. So you add all those up, it gets to 20. So we'll look at an example of this at work, and I'm going to take carbon. So if I take an atom of carbon, and I'll take the most common atom of carbon, carbon 12, we have 6 protons because their atomic number is 6. Our neutrons also 6 because the mass number is 12. So 6 plus something must equal 12, and that something is the neutrons, and it work out as 6. And our electrons. Now, in order to work out the number of electrons, we need to know what the charge is. And because there's nothing written here, the charge is balanced. There's 0 charge. It's neither positive or negative. So the protons and the electrons must balance each other out. So we must have 6 electrons. So if we put our nucleus in, and then I'm only going to put 2 shells, because that's all carbon has. Electrons try and get closest to the nucleus as they can, so they fill out the inner shells first. So we've got 6 electrons to put in. I'm going to put the first 2 in that first shell. Now that's full, the next electrons will go into the shell after, and I'm going to put the next 4 into there. So that gives us our 6 electrons in total, 2 in the first shell, 4 in the next. You may see this written as an electron configuration as 2, 4. How you put them around the shells doesn't really matter. I've kind of drawn them in a way that helps later on, pairing up the electrons where I can, sometimes not, but I've paired them up here and there. It does not matter. As long as you've got 2 in your first shell, 4 in your next, doesn't matter where you draw them, that would be carbons. Now this information is really useful. If you go to your periodic table here, and we'll find carbon on the periodic table, just up here. Up on the top, you've got these numbers, and these are our group numbers. If we have a look at carbon, carbon's group number is 4. If we have a look at the number of electrons in its outer shell, we've got 1, 2, 3, 4. Now this matches up for all the elements. If we draw their electron configurations, see how many electrons there are in their outer shell, it will tell us which group on the periodic table they're in. If we take an example of this, we'll go this time with an oxygen atom. I'm going to take oxygen 16. So protons 8, neutrons 8, electrons 8, because there's no charge, so it'll balance out. Put my nucleus in. I'm only going to need 2 shells, so 8 electrons, 2 are going to go in my first shell, and then I'm going to have 4, 5, 6 in my next shell. So 1, 2, 3, 4, 5, 6, 7, 8, and that gives me 8 electrons in total. Now if I look at the outer shell of oxygen, it has got 1, 2, 3, 4, 5, 6 electrons there. So we can have a look at our periodic table. We're going to predict that it should be in group 6, and oxygen's here, right below the number 6. So far, matching up. We'll try a slightly bigger one now. Let's try sodium. So, Na, I'll take sodium 23, protons 11, neutrons, this time 12. It's not double. If it was 22, it'd be 11. It's 23, so we've got 1 extra neutron than we have protons. Then our electrons, no charge on this atom, and there never is on an atom, so our electrons are going to be 11. So this time, put 2 into my first shell, and that fills that up. I'll draw my next one, and I'm going to have a maximum of 8. We saw earlier on this diagram that the second shell could only hold 8 electrons. So I filled it up, but that only gets me to 10. So I'm going to put another shell on and put 1 more electron in there. So that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 electrons. Outer shell, very outer shell, I've only got 1 electron there. So have a look where sodium is. It is in group 1. With 1 electron in its outer shell, goes in group 1. And that's how the electrons are arranged looking at this Bohr's model. Right. Group 0 or group 8. You'll see it written as different things. It may even appear as 18 on your periodic table. We're going to stick with either group 8 or group 0. So we have a look at neon. I'm going to take neon 20. It's got 10 protons, 10 neutrons, 10 electrons. So 2 in the first, 8 in the final. Now that group 8 would fit with this description. Group 0, you could either say it's because the next shell is completely empty, or it's because this is completely full. It's a full ring around. Either way, it doesn't really matter. It'll be referred to as either group 8 or group 0. Because its electrons are full, this actually doesn't react very well. And it also accounts for one of the weird things on your periodic table. Why does helium with 2 protons, 2 neutrons and 2 electrons appear where it does on that far right hand side? Because the first shell holds only 2 electrons, that's full. Helium fills up that first shell. There's nothing in the outer shell. Because it fills up its outer shell, it means it's not very reactive, and it behaves exactly like the other group 8 atoms, so neon, argon, krypton, xenon and radon, all behave very similarly. So we put helium across with those elements. So although strictly speaking it doesn't have 8 electrons in its outer shell, there's one that doesn't quite fit in, it does have a full outer shell, and so that's why it appears there. This is all really, really useful when we come to ionic bonding, and we can show how ions bond by drawing Bohr's model figures. Below is a practice worksheet just to give you a bit of a go at identifying atoms from their electronic structure. If you give that a go, there are a few questions when it comes to ions. So if we have a look at one ion, we'll have a look at F-. Now, 19 and 9. So protons, 9, neutrons, 10, electrons. It's got one more electron, -1, doesn't matter really which way, one more electron than it does protons. So it must have 10 electrons. So now, when we draw its electron configuration, we can add 10 electrons in. Now, this could very easily get confused with neon. So to identify this as F-, we show it's the fluoride ion by putting brackets around it and then what the charge is in the top right-hand corner. And then we could work backwards to identify that this is a fluoride single minus ion. It's really important on ions that we put the brackets around to show that it is an ion and what the charge is on the ion. So we don't confuse this. This would be, without this, that's neon. So this is fluoride, or the fluorine -1 ion. Can go the other way, of course. We could have, let's do lithium, 7, 3, so 3 protons, 4 neutrons, 3 electrons. If we said it was +1, it's going to have lost an electron. It's going to have one more proton than it does electrons. So this time, lithium only has, or lithium +1 only has 2 electrons, so it only has that first shell full, and it's now a +1 ion. So we put the brackets around with the positive to show that they've become ions. So a couple of those to practice as well on the worksheet. So give those a go and good luck.